Let's do this. Hi. So, my name is Ólafur Waage, and we're going to be talking about Sandbox games. It's me. It's my face. Very pretty face. I'm a senior software developer at TurtleSec AS. We are a consultancy company in Norway. And yeah, we do consulting and training and all sorts of fun things. And you can yell at me on Twitter as well, which is very productive. This is the lovely logo. Yes, you should visit us. For every talk that is out there, you need a quote by a philosopher, right? I must go forward where I have never been instead of backwards where I have, right? We need to learn new things. And for those who were at the lightning talk, it is the same philosopher. Yes, and I think I called it a physicist in the talk, but that's not good. Not good. All right, so this is the classic one, what this talk is and what this talk isn't. I'm gonna move my phone so I can see what time it is. There we go, good. We're not gonna go into game development directly. A while ago I was making a game and I wanted to make it using WebAssembly to learn more about it. And this talk is kind of basically all of the walls and all of the things that I stumbled upon on that way, right? So I want to teach you about these things, so when you go and try this out, you don't have to worry. This is also not a comprehensive WebAssembly talk. I will talk a lot about WebAssembly, I'll go into the details, and a lot about how you can do things yourself. But what I found when I was learning WebAssembly myself is there were a lot of technical talks out there that were very detailed, going into the nitty-gritty and the bits and the bytes, and those talks are great. So this is more of like, hey, let's get something going. Let's have some fun. And then you can go into the more detailed talks for other fun things. And yeah, idea is to be pragmatic, learn what this tool has to offer, and what problems we can solve. Good. So, what is WebAssembly? How can something be neither web, technically, or assembly, also, technically? It is a binary file format. Think of it that way. It was originally set up to execute performant code in browsers. That was the general idea in the beginning. Phone call. Announced in 2015. We got a working draft in 2018. W3C recommendation in 2019. And a nice way of thinking about WebAssembly is thinking of it as the binary target output. So it really doesn't matter what language you're programming in. If that language then supports that the binary output is a WebAssembly file, all right? So that there are, I think Rust supports it natively, there are TypeScript outputs, and in this one we'll do C++. So that's the idea. It looks kind of like this. This is one of the functions that we will look at. It is a stack-based language. So you always put things on the stack, and the return value is the last thing on the stack. So in a sense, it looks kind of like assembly. You have these really simple instructions and then the arguments afterwards. Here we're defining a function called getBoardSize. If I remember correctly, yeah, it takes one argument, puts that argument on the stack, and then for this one, I think it's only I think it's optimizing here away things, because we need the argument to find out the value from the stack, all right? But yeah, it has more things, it has conditions, it has loops, and that kind of stuff, and we'll see more detail there. Many of you might associate WebAssembly with games only, like it's only for game-based things. And even though, yeah, we're gonna talk about that, games serve as a nice hello world, games serve as a nice way of showing you things, but don't one-to-one associate it with that. And we'll actually see that on the way, where it doesn't need to be a game, it just needs to be some sort of code. So as an example, here are some things that you might not have thought that were written in WebAssembly. Someone took the Microsoft calculator, because Microsoft open sourced the calculator a while back. So this is the actual code for it. There's a website you can go, calculator.platform.uno, and then, yeah, all your calculating needs. For those of you who use Figma, Parts of Figma are in WebAssembly. I'm not sure which parts there are. They haven't disclosed that, but they use WebAssembly a lot. Someone made a photo editor in WebAssembly, and I think Photoshop as well has moved their stuff onto the web, and that's also WebAssembly. Like I say, it doesn't need to be games. So TensorFlow, which is a machine learning library, they have TensorFlow.js, and running that to WebAssembly gained them quite a bit of performance. And that's kind of the reason why people look at WebAssembly, not necessarily that it's sandboxed or you can use other languages. It's also that you can write code that runs performant on the web. Here's a use case where the web app that they had was 20 times faster. I think they do protein folding, so that's like a protein folding website. And yeah, it was quite the improvement. So think of this as not necessarily that you can use certain languages, there is a performance aspect of it. Cool. We're going to be using a tool called Emscripten. Emscripten is a tool that uses the Clang and LLVM frameworks to be an output for WebAssembly, for C++. And it's kind of WebAssembly before WebAssembly, because Emscripten is a bit older than that. We originally had a thing called asm.js from Mozilla. The goals were the same. Like, I want to run efficient code on the web. But it's a subset of JavaScript. And what would happen is whatever code you were writing, it would be turned into JavaScript. And then you would be running the JavaScript on the web. It had benefits, it had downsides, but at least that's where we started. And yeah, this is where Emscripten came to play. Emscripten could output for you asm.js, and that's where that tool comes from. Well, maybe not comes from, but yeah, that's where you could use it from. Based on LLVM and Clang, target the WebAssembly as the binary output. There are multiple different outputs you can use. What we'll do mainly in this talk, we'll talk about the wasm file, which is the binary file. But it also outputs JavaScript and HTML files. And you'll see something weird for those who haven't played with this. Our main output, what's it called? The extension of our thing will be .html, not .exe, which is kind of weird to look at. So let's go over the installation process. If you want to play with this at home or later, this whole flow, I've been going through this a few times, so it should be working as of today. The text editor we'll be using is VS Code. I'm using WS2 on Windows, running Ubuntu 20.04. The code is there if you want to play with it now or later. I'll also post it in all the fun channels. So, first thing we do, we run our favorite package manager, whichever one that is, and we install Python, CMake, and Git. That's what we need for that. We clone the Emscripten core, the EMSDK, go into that folder, do a git pull because I'm nervous like that. And we install latest. I'm hiding the outputs from each one of these, so there's going to be outputs, but normally they should be running okay. And I call EMSDK install latest. This will take a little bit of time, and then I activate the latest version. You can also say, if you know what version you want to run, I want to run whatever the version number is, and you can get a list of them. So the EMSDK is a whole suite of fun things. Good, then I activate the latest. And then what's nice to do is to set the environment variables. You can source the env.sh file. I also put it into the basrc. And if you want to find out what the environment variables are in this file, you can also put them in the path on Windows. So you can do that. So it's always there when you want it. Good. Everybody done this in the audience? Yes? Okay, good. When this is done, you can run emcc, which is the compiler. You can do version, and you'll get what is very similar to the Clang outputs. You get the versions and all of the copyright and liability things. You can also do which to see where it's from. So I have it in the home EMSDK, upstream, Emscripten, MCC, and that's where most of the tools are as well. So you can go into that folder and look at that. Good. So we have the system. Good. So it's the honored tradition, hello world, right? But there's a few more steps that you have to think about. The hello world we're going to use is like this. I'm sorry for the C. It's okay. We'll get through this. I will run emcc hello world.c, and I'll get an output. I have two files, aout.js and aout.wasm. So now, what do? I don't understand these files. So let's instead say emcc hello world, and the output is hello world.html. That's we normally think of that as the binary output, but we want the HTML file. And yeah, of course, we have the same. We have hello world HTML, JavaScript, and WASM. And these HTML and JS files are pretty hefty. And these are just normal HTML and normal JavaScript. You can read through them. But we'll go into what the JavaScript file is doing. The HTML file isn't that important. It has some things, but the JavaScript file is pretty important, and we'll bump into that later. And the WASM file is the binary, the WebAssembly output. So what you can actually do is you can take the JavaScript file, and I can run it with Node.js. For those who know what that is, it's the JavaScript runtime. But let's open the HTML file, right? It's an HTML file. I have a browser. Let's just double-click it and see what happens. And that's wall number one. So of course there's going to be a problem. And browsers don't like it when you open random files from whatever location. That's not what they like to do. Because within this HTML file, you want to be loading the JavaScript, and you want to load this binary file that's sitting on your hard drive. There's a thing called cross-origin resource sharing. And by default, if a browser is asking, if you're asking to load something from disk, they will say no. It's not going to like that. HTML will load, you'll get the basic HTML file, but that's not going to work. So you need to run a web server. So that's the first kind of hurdle you have to look at. But Emscripten has a thing called emrun, which is a very, very basic web server. And for development purposes, it's fine. If you go further, I wouldn't use emrun, because emrun is running from the folder you're in. So if you have any more complicated data structure, folder structures, it's not going to play very nice. And there's a few problems you'll bump into later. So I will run emrun. I have a port 8080, and I will give it the hello world HTML file. And what we'll get is this beautiful website. And at the bottom, in the console output, you'll see hello world. So yeah, this works. So let's look at that. So this is the repo. I'll go into the WASM hello world. I'll build the SH. Maybe make the thing a little bit bigger. There we go. If I run aout.js, I'll get a hello world. This isn't going to be happening all the time, but just for this case that we have right now, it does. Because what this program is doing is it's starting, it's printing something to the debug output, and then quitting. So that's what we're getting right there. So it happens to do that. But if I do a build HTML, I'll get a few more files. The WASM, as I said before. If I then run HTML, I'll have the whole thing. Good. Hello world is done. And we are happy. And then I have to do this. And then we'll continue. Okay. Now, let's look at the game we'll be making. It's a simple sliding puzzle game, similar to games like Threes and 2048. Let's do that. I will. So in the folders are numbered kind of after the process I'm doing in the talk. So if it's early in the talk, it's 1, 2, 3, or 4. So let's do that. And because the game itself is JavaScript only, I can run it directly through here, and I can press the arrow keys to move up and down, left and right, and it will merge the cubes if they are the same number. So it's a, yeah, pretty simple little game. Like it's enough interaction that we will, it's enough game state and enough interaction to have something on the output. So that's the game that we'll be porting over. The code for it can be pretty long. It's also long because I have the font size pretty big. But the interesting bits are here, where we are drawing, because we need to request an animation frame from Chrome. We wait for that. We will run an update and a draw to get the 2D context. I have a little simple, like a frame update loop, and then I will draw with the canvas. So this will run the update 60 times a second, but try to draw as often as you can. And this will also cause trouble later on. But for now, and then above this is just game logic stuff. You can look at that. But what we want to do is we want to move some of this code over. So the first step that we want to do is we want to take some of the JavaScript that we have here, and which is only going to be the game logic of the JavaScript. We're going to draw in JavaScript, but we're going to do the game logic in C++. So for the functions that we want to move over, let's move over something simple to begin with. Okay, so let's convert stuff over. Yeah, there are two ways to do this. We can keep the drawing in JavaScript, game logic in C++, or do everything in C++. We will do both, and there are other walls we will hit along the way. So let's take some of the functions we have. Some of them don't even need to know about the game state. They're just standalone functions that do helpful things. Here are two of them. Get random coordinate. This is used when you move a cube, it will spawn a new one in a random place. So we just need a way to get a random place. And then is outbounds, are you outside the board in some way? Either you're a negative number or you're bigger than the board length. So that seems pretty simple. Let's start with is outbounds. This is the whole file. This is everything you would need. We are including Emscripten. I have the board size as a context expert. I do an extern C. This is mostly for name mangling reasons, just so the name is a bit nicer on the other side. And you only need to do this for the functions that you are exporting over to the JavaScript side. The Emscripten keep alive is there because otherwise the compiler would remove the function because it's not used anywhere. That's the only reason. But otherwise, you can see that it's the same code. There's nothing else going on here. Okay? So we're happy here. And we compile it this way. EMCC, we do debug. Source map, I'll show you a bit later. No entry means that there's no main file. Because, yeah, there's no main function. We only want the WASM file. We don't want the JavaScript and the HTML because we're going to learn about that ourselves first. This is the file name, and then I want the HTML file out. Good. So on the JavaScript end, what we do is we need to fetch this WASM file. So we would put some JavaScript somewhere in our website. The import object we'll look at later. Fetch is just to get a file from disk. We get the results of that into instantiate streaming, which means that it's not going to block when it's loading the file if the file is very big. So we'll just try to stream the file when it's loading it. And then when that streaming is done, we have the results, which is the results of loading the file. So within results, within instance exports is outbound. There's our function. So this function here is now a JavaScript function. I can give it a name just so it's a little bit shorter. I call it isOutbounds, and this works. So now I have just a function. It doesn't do much, but I have a C++ function callable from JavaScript. All right? That seems helpful. And this works. We're happy here. The other code that's here is fine. So great. We're steaming ahead. Let's go to the next function. Get random coordinate. It does math floor and math random. That seems kind of simple. Math random times 4 gets it from 0 to 4. We floor it, just so we don't get the floating point values. Good. No. Wall number 2. There is no operating system. Okay. So, with a standalone WASM file, nothing else, there is no operating system level functionality. You're all on your own, kind of. So, how do we solve that problem? So, using random, calling timer functions and other OS level functionality has to come from somewhere. So, it either has to be implemented within your WASM file, or it has to be given to you somehow. And we'll look into that part of it. If you can implement stuff, if it's a library or whatever you're using, within your WASM file, you're happy. It's fine. It will work. But if you depend on something that can't be in your binary or binaries, you have to get that functionality from somewhere. So, thankfully, there's a solution to this. Normally what you do within Emscripten is, you've seen the JavaScript file that we got. What that JavaScript file, that was the pretty long one, it is giving you these operating system level functionalities. That's the purpose of that file, among other things. But the main purpose of the file is, what if you need something that you depend on that you're not implementing yourself? Okay? But best way to learn about something like this is, let's do it ourselves. And then later we'll use that output, but let's learn how that works and what that's doing. So, Emscripten has a thing called Emscripten_random. They have a bunch of library files. Emscripten doesn't have to have these, but it implements it for you. If you use the JavaScript file, and if you use the JavaScript file and the WASM output, you can call Emscripten_random and you'll get a random number. You will be happy and it's fine. But if we are standalone, we don't have this. So how do we use it? Okay, let's just put it there, see what happens. Right? Simple. So I've stripped away the other one. The other one should be there, but let's just imagine we just have this random coordinate thing, and we're going to call Emscripten_random and see what happens. We use it like this. For this example, I renamed the WASM file, so don't worry too much. Here's the whole HTML, just if you want to see that as well. So I'm just putting JavaScript there in. And again, the import object will look at the bit. I have get the random coordinate in the same way, instances exports, and I'm console login. I want to print out what this gives. And what do you think happens? It doesn't work. And the error is actually, it's weird when you see it first, but it makes sense once you learn a bit more about how this thing works. Module env, basically, error module is not an object of function. There's no env we're dealing with here. If you're looking at this, it feels like it's complaining about something that I didn't do. And there is a thing that's missing. And the thing that's missing is this import object. And that's the important bit here. Because the import object is your world, is your operating system, is your connection to the external world. That's why that object is there, and that's why it's given to you. Another way that I like to think about it is in the way of for us C++ programmers, it's your linking. You have some code, you did something, but there is some stuff somewhere else that I need, that I'm just going to trust is going to be there. So think of the import object as that. That's your connection out. Okay, it complained about a thing called env, which is supposed to be an object, so I'll just make an object called env. Empty object. What happens next? Well, the error is that function Emscripten_random, function import requires a callable, which is a way of JavaScript saying is it tried to call something and called something called Emscripten_random within env, and it wasn't a function it could call. That's what that error means. And what that means is that there's a missing function within the environment. Okay? So if we look at the WebAssembly output for this, so below, from F5 and below, that's our function. That's the WebAssembly for the function we're doing. It's having some fun there, doing some conditions and then returning. But above is kind of the definition of the world that you're living in. And in the second line, environment.Emscripten_random. We're going to import env Emscripten_random, and it's going to take one argument. That's the thing under module. So what it's saying is there's going to be something called env Emscripten_random out there that takes one argument, and No, sorry, returns one argument, sorry. Yes. Returns one argument, sorry. That we are able to call. And in F9, I don't know how well it is visible there on the screen, is us trying to call it. So this is our world. This over here saying we have this function called getRandomCoordinate. We expect something outside, and we're going to call it. And once it tried to do that, we didn't find it, it doesn't work. So let's implement random. So I say Emscripten random as a function, it returns math.random. I could return the number 4, I could return a string, it's not going to be happy about that, but this is now the implementation of random in my system, and I can control that. And now, this works. We are happy here with this function, okay? So, now we can move over to the rest of the game logic. Yes?
You completely lost me. At some point you have a sequence function that compiles, all the functions called Emscripten random. Was there a core declaration for somewhere? How does it work? Where does it come from? Because we didn't even make it.
Because it doesn't, we're calling something here that doesn't exist.
One on the left,
Yes. This one is defined, I think, within the Emscripten H file. Yeah, this is why we talk about it here. You can also, you can define things that, like, there's stuff going to exist outside that I'm going to call, and you'll see a bit of that later. But yeah, that's where the connection is for there. Yeah, there you go. Yeah, the question for was basically, where did this come from? Yes. Ba, ba, ba. And yeah, here we are happy. So we can move over. Most of the other game logic is pretty simplistic, so we can move over that. The board is going to be an array of boxes, and the rest of the game logic is identical. There was, I think, one more headache that was similar, like we just need to implement it on the JavaScript side, then we can move on. So now, the gameplay is on the JavaScript end, whatever the logic is of moving the boxes and what is where and what should be merged. But then the drawing is on the JavaScript side. So let's look at, no, let's continue. Because I think there's going to be a problem, yes. So we need the JavaScript side, the thing that's going to draw where are the boxes, what's the state of the world, we need that data. We need to get that somehow. We were able to call these functions, but we need to keep calling them and asking for, like, where's this box, where's that box. We can communicate between C++ and JavaScript using primitive types. So that's going to work. So ints and floats and booleans, that's fine. Once you have a bit more complicated types, they don't map to JavaScript. So if you want to look at the raw data within vector, you can, but a vector in C++ and a list or an array in JavaScript, they don't map to each other. That's not the same thing. So if you would say, like, oh, I'm going to write a function, I'm going to return a vector from that function and call it from JavaScript, it's not going to work. Not directly, at least. Yeah, because they're not the same thing. There is a thing in Emscripten called embind. So if you have a class that you want to then represent on the JavaScript end, you can define how it works. So you would, let's say that you have a class called myClass. It has a constructor that takes two things, an int and a string. You have a function called increment x, and you have a function pointer to that one. You have some property called getX and setX, it's called x. And you also have class functions, so you have a static there as well, getString from instance. If you bind it like this, then you're able to communicate back and forth because you've now described the rules of how you talk to the class, to the JavaScript side. So then that works. But it can be a bit daunting to keep writing these things for all your classes, but if you really need that class to go between, you can define it there. Emscripten or embind also has helpers. So if you need to send a vector over, it has basically defined this for vector as a helper for you. So you can just say register vector. There's going to be a vector called something. So you'll get the same functionality. So you can send the data like this over, but In the cases that we have, we're basically going to be thinking of the primitive types. But if you need a more complex type, you can do that. You can also define a shared block of memory. You can say that here's going to be 100 kilobytes. These 100 kilobytes are going to be able to be written or read from the JavaScript end and from the C++ end. So you can define that as well. And WebAssembly has definitions of, like, are they big endian or small endian? What is the size of a word? What is the memory layout? So it has rules for how things are set up. So you can have assumptions for when you want to write two things in C++ that they would match correctly in the JavaScript end. So if you want to have fun with just like, hey, here are a bunch of bytes, let's have fun with them, you can do that too. You can also return a pointer to JavaScript because technically it's primitive because it's just a number. But there's, yeah, you need to be a bit more careful what you're doing with that one. Okay. So, since I wrote the game logic in pretty simple primitives, we can finish converting all the functions over to C++ and export them to JavaScript. And let's look at that version of the implementation. So, for those who are looking at this, that is, so number 1 was the game only. Number 2 is the hello world of, no, that's the hello world, sorry. That's the here, 3, the game logic version of it. For the game.js, so this is the JavaScript version. I still have Emscripten random. The preview thing is an experimental thing within Chrome. I just put it there so Chrome would stop yelling at me. I'm loading the game logic wasm. These are the functions I expose. I can ask if a box is empty. I can call the update loop. I can create a box within the game logic. And then I can do a bunch of getters. Where are the x values, the height and the width? Yeah, those values. Then we have some JavaScript about the keys. I'm pressing keys left and right, up and down. I create one box, which is calling the C++ function. And then I do the same drawing as before. But instead of having that data in the JavaScript, I need to call the C++ functions to get the information from basically the cube, and then the same drawing code before. And then the same update as before as well. So there's no big difference here in the drawing part of it, but except that all the game logic functions are coming from WebAssembly. So let's run that one. So we go into 3. No. And we can build it. All right. We can run it, and I have the game. And it's the same game before. We can have a lot of fun, but there is now more that is happening. So if I go into the developer tools, and I go into sources, you can see that the WASM file is here, but also the C++ file is here. If you can see it, I can do like a little, maybe not too much. There we go. And what I can do is I can put breakpoints. There we go. And now if I move a box, I focus here, move a box up, I've hit the breakpoint. Even though I compiled it with -G to get the debug symbols, they're still not super helpful, because what's happening here is the system is kind of lying to you. When you put a breakpoint here, you're actually putting a breakpoint in the WASM file. So you get the names from the WASM files. You will get the function names, and you'll get some variable names, but generally you'll get you're putting a breakpoint in the WASM, and it's only helping you here. But I can step through. I can look at the values on the stack and hear all the fun things that are happening. I think also there is the call stack is here. So I'm coming from update. I'm going into create box. I can click update, see where I came from. So that's pretty neat. Same thing for the box. The box was just a class to represent the actual box itself. So that's pretty neat. All right. And you can see that the game logic here is pretty. I'm hoping when you're looking through this, it's relatively simple-ish C++. Then the getters are here, just getting the values. Good. Any thoughts or arguments so far? No. How are we on time? You reminded me of a thing that I was missing. So, I can go to performance. I can click this here. I can click up and down, left and right a little bit, then click stop. And now I have a screenshot of the game being played. And I'm saying like, here was the problem. So if I click there on here, you can see, if I can I zoom in on this? Not with this mouse pad, here we go. No, it doesn't want to zoom in. Maybe if I click it. This technology is amazing. But anyway, why is it not wanting to zoom in? Come on, be nice to me. Maybe if I'll go to the old technology while you think of questions to ask. I do not have a free plug. Oh well. But anyway, these are the call sites. I find it amazing it doesn't want to zoom. Windows Update. Yes. We're all happy here. Okay. Anyway, yes, you can see you would see the call to each function and how long it takes and all these wonderful things. I can double click at least. Yes, okay. You can see the CPU usage. So these, for those who are familiar with the Chrome DevTools, you should be able to see this here. No. No? Oh well. But yeah, so you have this here. You also have memory. You can do heap snapshots. You can see if you're leaking any memory. So I can load this here. And then I can do something. I still have the breakpoint. Let's remove that. Go into memory. Have some more fun. And I can take another snapshot. And I can compare them and see what's going on. So here I allocated 300 kilobytes for some reason. You can see where that's coming from. Cool. Okay. All right. So now we have everything. And think of this as, like, let's say you have a library. You have some sort of tool you want your users to use, or you have something on in a website that isn't as performant as you want it to be. It doesn't have to be a game. If you have a tool in C++ that you want your users to use on the web, you can compile it to Wasm and call it from the JavaScript side. In the same way that I've been, like, it doesn't have to be a game. I'm just calling some functions. But also in the way where if you already have some sort of JavaScript UI thing, and it's not performant or there's some problems with it, you can write it in C++, call it from JavaScript, and then use it. Should be better there. So, we don't have the rendering, so let's move that one over as well. And that will also cause a couple of problems that are related to us, even though we're not doing games. Emscripten has built-in support for a bunch of things that we need. They have support for a thing called SDL, which is like a general library for making games. It has not only for graphics, it has input, it has sound, and all these wonderful things. They also have support for SDL2, and this also shows a feature within Emscripten where you can download dependencies. So in your build script or in your build commands, you can say use SDL2, and I also want to use SDL, the TTF, the TrueType font library. You put those in. There's one catch if you're trying this at home. Within that folder, there's going to be a script called first time install, because there's kind of a chicken and the egg problem here. If you set up your project and you try to build it, and you don't have SDL downloaded and installed, but you already depend on an SDL file that's not there, it will build and fail because the downloading of the SDL happens afterwards. So there's a small script in a project, you can just run it. The only thing it does is it depends on SDL but doesn't do anything. So it will download SDL for you. When you're done with that, you can just delete those files if you want. All right, I will use STL2. And that will kind of also show you more of when you're depending on something from the outside. And here, we're not going to create the import object ourselves. And I will show you this import object later, but now we're going to look at the JavaScript file itself. For STL, I can call STL init, for those who are familiar with these. I can open the font, make a little cache, get some other timing information, and then there's a thing called Emscripten set main loop. So what this will do is, this is the function that's going to be called as often as Emscripten can. Because in games, you need a game loop that is running again and again and again. Because we were calling this from the JavaScript side, we were calling update every 60 times a second or something. Now we can't do that. That has to be done from Emscripten, so that has a set main loop. So this is the function to call again and again. I poured over the rendering code. I'm not going to go into the rendering code itself, because it's not that kind of talk, but you can look at it. It's relatively simple. And what I did in the beginning, when I was porting over the rendering code, is I started with just the color. I want a red box, nothing else. And I'm going to wait for displaying the text. So I convert it over, I make the box, and everything compiles. We're happy. I run the code. I see the red box for a second, and then I get this. All right. Cannot enlarge memory arrays to size. So, we're in trouble now. And it's talking about memory and abort on cannot grow memory, basically. So what is happening is the sandbox isn't infinite. That's wall number 4. Up to this point, everything I've been doing has just happened to fit into whatever the default memory size was in the beginning. But now since STL2 is involved, I'm loading textures, I'm loading fonts. Yeah, the memory is going to blow out of control. There are a few options you have. You can set the initial memory, you can set the total memory, and you can also say that you're allowed to grow the memory. So I have all these 3 here, and I have them in the build script as well, so you can just see them. You don't need always have to have all of them, but it's good to know that this is a thing you have to think about, because even though you're in a browser, you have limited memory. Great, so we're happy for now. We can see box on the canvas. So let's do the text. So we have a red box, that worked okay. The next thing was to print a little text on there. Before, I didn't use a font library because I was using JavaScript to draw the text. And since it's web, it has text support and all that. But now, since I'm actually making this as a texture, like a little picture, I need something to put the text on there. So I need a font, okay? So I should load the font, get the texture for the font, put the texture for the font on the red box, and we should be happy, okay? And that's wall number 5, file not found. Because the environment we're in doesn't give us much from the outside. We've talked about before that if you want functionality from the outside, you have to get that from JavaScript. But what if it's not functionality? What if it's file? What if it's data? So there isn't a file system, not in that sense. So yeah, the font file we want to use doesn't exist, and the idea of a file system is different from what we expect. And what you have to do, there are 2 ways to do this. You can embed the files, or you can preload the files. And what I do here is a preload of a file. What you can do is you can preload a folder. So in the project I have a folder called assets. It's / assets, because in this version of the project, the file structure is a bit different. So we have a source folder, and then you go back, and then you have the assets folder. And what this is doing is, it's mapping that folder, the /assets, to / assets within the WASM. So it's telling the WASM file, there's going to be a folder called / assets, and within that, there should be whatever files were in the previous folder. So now, when I do the font loading, I can say / assets Arial bold, and that works. So now I have that file. So if you depend on files or data or some maybe ini files or whatever you have to load, they have to come from somewhere. You cannot magically just access a file system because, again, we're in a sandbox. So, yes. Emscripten also provides some helper utilities for you. if you want to make a development environment. It has tools for CMake and Make. So you can, if you use the CMake and Make, you can use these. They're called EM Make and EM CMake. And what they are they're Python scripts that will set up some of the environment stuff for you and then just call CMake or call Make. So I can do EM Make clean and I can do EM CMake. So this is going to look odd as well because these are the Python scripts. And then you tell them what command you want to run. So you say EM CMake CMake. Because you might also want to define what CMake you want to run, because you might have a CMake within your system. Like, no, I want to run this specific CMake. So you can say EMake CMake, and then, yeah, and that will run. And because you have Make and CMake, you can make CMake files. So this is the CMake file for project number 4, the full one. The line number 3 there is funny for some, because the CMake executable suffix is .html, because that's the output that we want. I can add the files just like I want. I'm defining the version just like I want. And then what I've been showing you over these slides are the EM flags that I've been setting. I can say that here's the preload file, the source map. The source map thing is for when I wanted to show the CPP files to browse into them and put the breakpoints. So you need that for that. Here are the STL, the memory things that I had before. But you notice on the second line for the EM flags, I have address sanitizer. Yeah, because this is built on top of Clang, you have all those tools. And guess where the memory thing came from? Yeah, it came from there. You can use Upsun, you can use address sanitizer, all these wonderful tools that you have. You can also say profiling. That helps also with the profiling tools I had there in Chrome. So yeah, there are quite a lot more. The shell file, if you want your own index.html, not the default one given you by Emscripten, which has like the logo and everything. So if you want something more simpler or has your branding, you can do that. But otherwise, yeah, you have CMake, right? That's cool. So let's look at that. Let's go here. I can turn this off. So now we are in project number 4. Here's the first install I talked about. It's a very complicated file that has just int main, nothing else in it. But the sh file has the install of use STL and STL2 and just points to the file, so it's not doing anything else. So I can just say build. And you have your classic CMake output that you know and love, right? There we go. And also, for another thing, just to have things a little bit more different, instead of using EM_run for this project, I'm using a Python web server, because, yeah, you can. So the only difference I had to say was I had to teach it about .wasm files. I had a problem with one browser, don't remember which one it was, where it didn't know how to load the wasm file. Or it thought it was just plain text. Let's just say it's application wasm. But otherwise, it's the simple Python server. So I can just say Python server, serving at localhost. So now when I go here, localhost, it's under build and game. There we go. I have the game. So now this is no longer being drawn in JavaScript. These things that you're watching there are textures that are built in STL, even though the game is running the same. And there is one problem that if someone is watching or here in the audience knows about, that even with all of this, all of these beautiful things that I've been doing, it doesn't give me the CPP file in this version. And I don't know why. I think it has something to do with how I'm setting up the folder structure. I've been going onto forums, but whatever I do not get. But I do get my home folder. So, yeah, if someone knows what is going on, they can let me know. I did get it at some point, but then that was when I moved the files all to the same folder. It was easier for it to figure out what was going on. But I have a little bit more. I have the files in the source folder. And then, yeah, for some reason, because the WASM file is in a build folder, the code is in the source folder, so then it wasn't very happy with it. But you still have the WASM file, which is, yeah, pretty big. And you also have all the other wonderful tooling. Let's see if I can zoom in now. Stop the profiler. Yeah, no. All right. The performance on this one is about the same, because the game isn't doing much anyway. But yeah. So, let's look at then the output file, because now we have the game HTML file, which is, like, it has some stuff in it for the key stuff I had to put in to handle the key presses. But if we look at game.js, you can see that we have this very, very big file. And what this file is doing, if I do .wasm here, we're saying that the binary file is game.wasm, all right? It's used to locate it, and then it's reading it. It's reading a bit differently, but it doesn't matter that much. Yeah, we have read. And what we will do is, because we're using SDL to draw, what SDL is actually doing, because we haven't implemented SDL in the WASM file. The WASM file isn't big enough for that. It's using WebGL, which is available for most browsers. So if I do Control F here and do WebGL, it's getting the WebGL context. And if I go down a little bit, here. So if there's a function like GL uniform 3i being called from SDL in some way, whatever that function is needed, this function is then mapped over to the GL context, which is the WebGL context. So we don't actually have GL or WebGL implemented within our WASM. We treat it like a syscall, if you think of it that way. We need that functionality within the WASM. So think of it as like the random that we did before. So if I actually go here and look for this function here, Emscripten uniform GLI, here, it's mapped to, this just seems to be a map, mapping the function name to the actual function pointer. And if I cut out this, you can see all the functions here. These are the depending functions. That this is the library. And we have env, like before. So we are defining that this function is this function pointer, that function pointer, and then this info, they call it here, just is given to the WASM file here. WebAssembly instantiate the binary and the info. This is the same thing. So it was doing the same thing for us. So this is the part of what Emscripten is doing for you. And if you're using other tools like Rust or TypeScript, they will generate these files for you. And so some of the dependencies that you need might be provided by the tooling you have. And for some of the questions that I've seen online of like, oh, why don't they have yada, yada, yada functionality? It's often just a case of they just haven't implemented it yet. Or they're thinking about it in a different way, or the answer might be, you have to provide it yourself. That might be the case. Okay, so we are okay on time. Yes?
How do you tell SDL which canvas to draw? Because you might have multiple canvases in the HTML. How do you tell that where to draw?
So multiple... So it's a canvas that has the ID canvas, which I think is the rule. Yeah. I think there's another way of doing it if there are multiple canvases, but I think if you give it the ID canvas, and I think if you instantiate, I think it might be a flag when you're building, you say like, oh, I'm going to use a canvas called something, something. That's the one you use. And also if we look at, if you go to the source code for the game logic, that here, I'm just saying SDL create window and renderer, and I'm saying 400, 400. There's nothing here that tells you what that is for. But it is there are assumptions here about what canvas you're using. And if I would resize this and rebuild, the canvas would grow. So this is actually setting that for you. And we can probably look at the, see if we go to the HTML. Canvas is up here. So here we're fetching the canvas, get element of ID canvas. So here we're assuming, this is for the WebGL context. So that's not that. Yeah, so this is another way of fetching basically the web state that you have. You create a module, and there's a canvas function, and you can give that to, where was it? Or no, I think it might be because there's a module that exists, and then you use the Emscripten, the JavaScript file here. It looks for the module file. I think that's the case. But yeah, and this is why I looked into, because if you would just do the default thing of just, I'm going to make the HTML file, I'm going to make the JavaScript file, the output I get is a gigantic JavaScript file and a gigantic HTML file, I don't know what's going on. But most of the things that are happening within the JavaScript file are just defining external dependencies that you need or might want. That's the only thing that's happening. So it's kind of nice to see that, how you can do that. And you can see the process from project 1 up to project 4, where we're stepping through, and you can run these as you wish. So we're good for now, all right? So we'll summarize, but there's a thing as well. The walls are, the files need to be served while developing. So if you have an HTML file or JavaScript file, it needs to be served to you somehow. You need a web server because you can't load these files directly. All functionality that you depend on, operating system or even libraries, have to be implemented or given to you from the external context. Data needs to be primitives or converted in some way before you can actually use it in the JavaScript. Memory size and memory growth needs to be thought about. And any files that you need or require need to be embedded or preloaded with the output. Okay. Who's here too old for this? One more thing. So, one more thing. Because I am a nerd, and you always go 110%, here's an extra. Let's play Wordle. Who wants to play Wordle? What's their favorite word to start with? Build? Oh, we have a U. We have a crane. No. I don't want to do this. I want to cheat. So what's the word? Mouth, okay. We're really good at this, right? So, I also made Wordle, because I thought projects are different. It's sometimes good to see things in done in different ways, slightly different ways. So I don't only have that one game, I have 2 games for you. So I have the sliding game, and I also have Wordle in the same way. So, if I close this, and I go to extra, not capital LL. Yeah, we can run that directly. If anybody here has sensitivity to blinking lights, look away for a second. I will let you know. It shouldn't be that much, but I will let you know. Here, this is a Wordle bot. If I shrink this a little bit, might be a bit better. And I can hide the thing, so you could look now if you had it. We are playing Wordle. The bot is pretty naive, and I made it naive basically for anybody watching. The strategy it's doing is it's making a random guess, taking all the correct and the wrong things that it found and filtering the big word list from that one, and then making another random guess, and then basically filtering again, and it keeps filtering and filtering until it might win or lose. The winning percentage is about a bit below half, which is not great. So if you want to optimize, you can have fun. But this is the JavaScript version. And we are playing about 34 games a second, which is fun. We played about 2,000 games now. So let's move it to WebAssembly, right? We should get faster games. right? I'm setting you up. There's a lesson in this. So yeah, 34 games. This is pure JavaScript. The word list is like 15,000 words, so we should be able to optimize this, right? C++, we can do it better, right? Cool. Again, setting you up. So, in Extra 3, we have the WASM version of this. So let's try that one. Extra 3, in the same way, I can just run build. And then I can run HTML. Again, if you have sensitivity, look away just a second. Here we have the same. I'm still doing the drawing in JavaScript, but the drawing for this isn't kind of the bottleneck. But there's a problem here, right? This is the WASM version. I'm still running about 35 games per second. What's going on, right? And this is one of the traps you can also fall into. Who has a guess? What's going on? I gave a hint earlier in the talk that this... Sorry? So the whole running of a game is a few milliseconds, both on the JavaScript side and the WebAssembly side. So there is some delay in sending data over, and that's communication, but that's not what's biting us. And now I'm kind of annoyed that I can't zoom. Let's try it a third one time. If I go to performance, maybe if I can just do it really quickly. Yeah. We have the game. No, I can't still zoom. Not happy with that. Up. Oh. Come on, be nice to me. Live demos. I know what to do. I will remove the clicker. That's how we solve this. There we go. Oh, high tech. Okay, so if we zoom in here, we have call to update. It is taking 54 microseconds. So the actual game, to solve one game, is 54 microseconds. But what's going on here is this. Look at all this empty space. Here's some drawing things that are happening, but again, it's a request on frame, and the game should be somewhere here. Here, call to update, 49 microseconds. Why? What's going on here? Right? Sorry, yes. So, what is happening is, if I go to the game logic for the WebAssembly game, I'm just calling here's an update function. And this is, one update will basically try one letter, and then it will update the game state, and then if you call update again, it will try another letter. And if the game has been solved, or if you lost the game, it will reset, plus the games played, plus the games won, and then it will just guess again. It will keep on doing this. If we go to the JavaScript side, this one, we have the drawing of the stuff. And here I have draw, whoops. And here's the main. And we're requesting animation frame, but I'm calling draw. I'm not calling update. And I had initially update here in the same way I had before. I had the frame capping thing, and I thought like, no, that's gonna be a problem. So I moved it here to a call update, which is a set timeout with no delay. So that should be called with 0 millisecond delay. But these things are happening at a certain interval within Chrome. Chrome has a frame rate, right? JavaScript is running at a certain tick interval, right? So what you would have to then do is you would have to manage this on the C++ end. You would have to say, we're going to run the game as often as you can, but if someone is calling us to ask about the state of the game, we can do that. So that's another project if you want to look at to make the WASM game run faster, you can try that out. Okay? And you have the whole thing here. You have words.h. It's a context per array of string views, which was a fun data structure to set up. And for the whole word list, it's 12,000 words. Yeah. So if you want to have fun with this, you can. And the repo is here. It's called Talk ACCU WebAssembly. It's on GitHub. And yeah, that is it. We go here. Thank you. Any questions, comments, angry rants? Yes. Any way to do the debugging? So, yeah, the best thing that I have seen when making stuff in this is this, if we go to, close that one, the game logic version, this one, can grow it a little bit, for sources. So for debugging what's going on within, like, our functions called, the breakpoints here are really helpful. There is a, if we go to the, you saw from the beginning, there was a hello world example where we printed out the printf. We can see that in the, there's like a console output. So if we go into, hello, I think it is, let's go to the second one, this. So if you're printing something, it will show up there. So you have the print output. So those two are kind of the main things you have. If you want to send over debug data to the JavaScript side, you can also then just do a console log on that. But then you have to think about what is the type of the thing that you're sending over. But from what I have seen with this, with the sources, this thing here, is that when you put a breakpoint and you're looking at the call stack, it isn't super helpful. So that's kind of been the biggest thing that I've had an issue with. So I've basically found other ways of, like when I'm debugging problems in this, I'm either putting a breakpoint, like it's a pretty primitive way of saying, like, I would ask, is this value true? And I would put a breakpoint in the condition and build, and then I would see if we hit that breakpoint, or if I would be printing out stuff. But again, if you were running in a pretty tight loop, printing stuff out might be helpful as well. So that's kind of the experience that I have. Okay? Yes?
You mentioned, like, the last example, that you're basically limited by how fast the update repo for Chrome is going. Does WASM support, like, having a background thread?
Okay, so there's one thing that I have not mentioned. So thinking of, the question is about threads or threading. Threads are not formally specified in WebAssembly. It is they want to standardize what it means to be a thread within this environment. That has not, I think there's a proposal, there's some stuff that's been worked on, but it's not officially in the standard. But Chrome supports it. So Chrome has like an early, I don't know, alpha or beta support version for threads. There's also, there are flags within Emscripten called Asyncify, which will help you with some of these things. So there is movement to go into threads, but if you're using like actual threads, Chrome has support for it, but other browsers I think don't.
You could potentially pull the logic in the background thread and just pull, use the main input, just pull the...
Yes, and then that would work in Chrome and any other browser that has that non-standard version supported, yes.
Do you know what support is like on different browsers, thinking about Chromium and, for example, Firefox?
I did some tests on Firefox. It was pretty good. They have a similar dev environment setup. If I remember correctly, the cases where I was able to see the CPP file were in Firefox, the problem that I had. So it was a bit better there. Otherwise, this kind of experience is the same. And the general support for WebAssembly, like they support the 1.0, whatever the full standard is. No, from last I checked, Chrome was the only one that had the threading, but that could be different. Yes? Yeah, I don't remember the command, we can probably do like a, if we go into home, EMSDK, EMSDK help, I think you can get list, yeah. Here. So this is stuff that, this is a list of the versions. I didn't have the list for the dependencies, let me see. Maybe they didn't have a list of it. Let me see. Emscripten list of tools. That's not it. We do SDL2. Using libraries. Here we go. Emscripten ports is called, yeah. They reside on GitHub. So here. SDL, free type, CLib, PNG, boost. That's pretty cool. Yeah. So there's a. So these things reside here, and if there are more added here, you can pull these and use them. So these are your dependencies that you can use from there. Most of the stuff you have to either get from externally or build yourself. Any closing dad jokes, thoughts, rants? No. All right. Then thank you.